Okay, so let's get started. So today we're going to do Advent of Code Day 1 Part 2. So let's go look at that description real quick. Part 2 is mostly dealing with this sliding window, right, where we're measuring the to see if there is an increase or a decrease in the window. And some quick thing I noticed real quick is that the window shares two values. So really you're just comparing this one to this one. You say, oh, is this one larger than that one? And then you'd get the windows increase. Actually, no, right here. For A, B, okay. So basically, we're going to assume non-zero value. So we're going to have step 0 equals -1. Easiest way I'm gonna do this. I'm gonna do this quick and dirty. We're not here to optimize Python. We're here to get HLS working. So we're gonna do this system. And basically we're gonna say step 0 is gonna be the oldest, and it's gonna go step 1, and then we're going to we're gonna do like a little ring buffer here, or not ring buffer. What am I thinking of? Shift register. We're gonna do a little quick software shift register, and we're gonna say if step underscore 0 is greater than -1, and let me say 0 in this situation, and step, we want to increase, so we want to say is step 3 greater than step 0. And if we do this, we want to say count plus equals 1. Right? We get a 5. 1, 2, 3, 4, 5. So that answer is 5. And if we went back here and we did the example data set that we have, which is the stuff at the front, we get 1633. We're not going to submit this until we do this in HLS. So, I mean, this is relatively easy to do in HLS, and I think we do it rather quickly. So we're going to go here, and we're going to go project. Where can I save as? I guess I could just copy and paste it and change the name. We say new project. The way I can just copy the project, open project, close project, recent project. Let's try a new project. Okay, let's see if it just has everything. This may be annoying. So we're gonna copy and paste the project and then open it up and maybe change some names. So let's open it real quick. X up, wrong drive. C drive, X up. E, no. Where was the last project? Okay, so we open this project. Where is it? Okay. And oh, oopsies. We're going to rename this to part 2. And we're going to open the project. See if we can just copy and paste it that way, because it's super annoying otherwise. Okay. So all we're going to do is go here and put part 2. All these things. And we're just kind of going to do the same thing we did in our Python. We're just going to have, right, we're going to, have a step 0 equals, -1. Step 3, 2, 1. We just have an int count. I'm not sure if the pre-int count's really useful. Oh, this is just the pre-values. Yeah, so let's just go ahead and do that real quick. We're just gonna go 3, 2, 1, and pre-int count. We're gonna start this off at 0. So the in stream we read temp, the temp data, right? So we're gonna write these values, but the thing is, we if we're writing them, we can't use them. So we have to write them at the end. Right? So do we need to put in step 3? I don't think we need a step 3 because the input data is what we're using. So we don't need that per se. And then we're just going to shuffle everything backwards. And we're going to say if step 0 is greater than 0, and step 0, I guess we could probably just say, but we'll just do it this for now. We're going to increment. Yay! I guess we'll slap this thing on here as well, just to call it good. Yeah, so I think that's all we need to do to get this one up and running. So let's go ahead and just run the C simulation real quick to see what the values are. And then we'll get this up and running. Oh, that is not the correct answer. That should return a 5. So what is happening? Let's try this to see how often these things happen. I'm a little confused. We got 3 values and then we got 5 values. You stop doing that. Okay. I guess we'll do that. Okay. So let's print out the values, right? So so we want to do so we'll do %x, %d, 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 right? And we're gonna go step 0, step 1, step 2, step 3. Great. Debug all this. So we need to figure out why is this not working? So throw in some statements, and it's not happy about our statements. I think I need to cast it. Oh, step 3 doesn't exist. My bad. It's supposed to be temp data. Temp dot data. Run the C simulation. Oh, so we have it at 1080p. Let's see. I could try to. Let's see if we can get the screen a little bit closer. Do a zoom of 175. Yeah, it's not really updating the text. I'm trying to look into why the screen. Unfortunately, the tools aren't set up for me to be like. Can't really zoom in on the text at the moment. But I'll try to look into a way where we can upgrade the solution a little bit better. I could try to do it the other way. Let me see. Okay. You guys aren't too worried about seeing the screen. Actually, let me go back to the other resolution real quick. And we can try to okay. That's probably the best we're gonna get right now. Okay, okay, why were we not happy about this? I spelled temp wrong. There we go. So we're just going to run the C simulation again. Okay. So those are -1. Why are these values not updating? I cast it as an int. Are you happier then? What if we put it after the state? These are supposed to stay. Oh, it's addresses. Ah, they're doing memory addresses. Terrible people. So I think the issue is the way the app init works. Let's put this at the beginning to figure out what the issue is. Ah! Spelling mistakes are getting me every time. Did I not? Did it not save? Oh, no. Hopefully you guys are seeing most of it. I know I did shrink the screen quite a bit so you guys can get some good visuals. Okay. So the 199 is greater than the 210. Oh. Supposed to be if it's an increase, so that's going to be step 0 on that side. Okay, so we're going to run this. Okay, I'm happy with that. We can leave the print statements in there if we want. I guess we could like tag it like this, put it over so you guys can see a little bit better. Okay, next we're gonna do we're gonna run the C synthesis and make sure that warnings. How do I get the warnings? Errors. Okay, so it doesn't want us using printf in our final solution. I need to make a statement for that. Okay, so it's unhappy about the printfs. I wish it would like be like, well, of course you can't do a printf, you know? I think I should be smart enough to do that. Okay. Oh, I got more errors. Oh, I need to go to my project settings, my solution settings, synthesis. That's not it. Project settings right here. We're doing the old function, so we go synthesis. We need to do part 2, and then we can run on active solution. Now we should be happy. Okay. Where's my information here? Why is it not showing me anything? Is it because we messed with the yeah, I don't know why that's GUI's messing up right now. So yeah, we do have, it's basically the same thing. So let's go ahead and export this RTL. Part 2. Part 2. We're gonna export. Probably gonna have to bring the window back down, guys. I don't know how you guys are gonna see the next part or not. So, we've properly exported the design. Now we're gonna go to Vivado, bring up the diagram. So we're gonna go back to our IP catalog and we're gonna refresh it, refresh all repositories. We now have a second one. Oh no, part 2. Why did the name not change? Ugh, let me go fix that. I don't like it being 2 names. So we're gonna go solution, export RTL. Part 2 needs to be part 2. Did I not get updated? Okay. Cool. Now it's exported. Now we go and refresh. Why? Fix settings. Solution settings. I don't know. Okay. Let's try this again. I want it to say part 2. Okay, display name. There we go. Part 2. I don't know why it's giving me so much pain before. Ah, whatever. I gotta block properties. Fix that name real quick. We're gonna run connection automation. Okay, so we now need another DMA. This is gonna be we're gonna change this guy's name, right? We're gonna change him to part 1 DMA. Part 1 DMA. Now we're gonna go. You're gonna say part 2 DMA. And we're gonna run connection automation. Boom. And like that. Organize. Validate. And we'll generate the bit stream. It won't take much longer. And yeah, we'll move it over to our thing. I can show you some cool features. I've been playing around with PYNQ. Why does this look terrible? Oh, let's go to interface view. The interface view would probably look nice. There we go. Let's do the interface view. Reduce jogs. No loops. No loops is a fun one. No loops. Grouping and no loops. Color. Ooh, addressing view. I don't see anything. Color coded. I should do color coded more often. Sheesh. Yeah, look at the color coding. Okay. So yeah, let's go ahead and generate. First, we're gonna go report IP status. Okay. I don't like what that's saying right there. Let's go. We're gonna have to go and play around with how this is exporting the RTL. Is it because it's on the part? Oh. So we'll go to the part 2. Oh, it overrode it. I need to go to the part 1 and fix it. That's what's happening. Okay. Now let's see if that fixed it. Why? Why? Why does it say? I want to fix this. Gotta figure out why. Project settings. Let's go HLS part 1. Or is it even using those? Is it even using those? IP catalog. Refresh. Not even using those. So it's something. Solution settings. Must be something in our synthesis settings. Where is this coming from? Okay, now we're going to export RTL part 2, part 2, part 2. And now it should create a IP folder. So this is the IP folder referencing. That's good. Ah! Where is this name located? I need to go. Really annoying that it's doing that. I'm curious. I wanted this to work properly so I don't have to deal with this in the future. Referencing the wrong depth file. Oh no. Oh. Oh no. Okay, so we're gonna have to create a new one every time. We'll just have to deal with it. So we're just gonna have to call this taxonomy library. I rewrote over the part 1 because the files are here. Where is this property? Where's this one located? So part 1 source. And we've been editing it. Yeah, we've been editing it. Ah, no. Not good. Oh well. Solution. We're just gonna have to call it good. There we go. Whatever. We're gonna add blocked IP. Look it up. We're just gonna have to call it good. line runs. Okay, oh. So when we do day 2, we'll have to do this the correct way. Okay, sorry, I was trying to get that fixed. Let's generate bitstream. Oh, it's whatever. Whatever. We'll make it pretty next time. Issue of HLS, it links all its sources, so it automatically connected all of them. That's annoying. Okay. So while that's going, we can show you what I was previously doing. So it's really cool that I figured out there's when we do the top function. So this is top function, or in other situations, this is going to be our day 1 part 1 HLS function. So we can add our function as an object, and we can look at the register map. And so this int count is what we were looking at this address right here, and it says it's in 1603, which means we can then do like dot int count dot address. Let's just do int count 1603. If we do count, what's that do? It's width 32. Okay. Interesting information we can get from these registers. Access, read only. Okay, so I'll have to play around with these things again. So let's go ahead and get this ready. So this is going to be what? It's going to be part 2 DMA, right? I have to part 2 underscore DMA, and below that we're going to do part 2 HLS, and it's going to be what, day 1 part 2 underscore 0 in this situation. And then we want to maybe take a gander at the register map. I do want to see if we can want to we're gonna make a quick file copy real quick. Rename part 2 CP our we'll get this later. We'll figure out how to, I don't need to be a scout. Stop it. There we go. Okay, that's part 1. Okay, that's good. Now let's go to Vivado. So we're doing the synth design portion right now. Hopefully, did that earlier. Okay, didn't redo right now. That's good. So we should be able to look at the HLS as soon as this finishes. Let's go ahead and figure out how we can time things. Python time functions. Time. So yeah, okay. Let's go figure out a good way to measure the performance. Right, we can call this a function if you wanted to do it right. let's go insert below, right? We're gonna make this a function. Python functions. Because my brain does not remember at the moment. Yeah, we just need def, that's fine. Def. Part. Pi part 1. And let's do pi part 1. Okay, cool. Now we do a cell below. Go back to this time function. We're going to run it 100 times, right? For x in range 100, run, and then divided by 100. Our average run time, 0.114. Now, they had this, we had a wait right here, right? Wait. And if we do the time on this, I wonder how is it going to be any different? I mean, if we had a larger list, maybe. There's 3 zeros. So we got a 10x improvement by using HLS. Yay, hardware acceleration. Let's we're gonna have to go through and figure this out. Okay, that's good. And not reset it. Oh, we're not doing. Are we not doing a last? The last should clear it out. Huh. Maybe we need to do a clear. Okay. Okay. So if we say dot clear input equals 1. That do. Oh. Need to toggle it. What if we got rid of the 100 times thing? We just ran it for once. Let's try doing a bit. May not be happy with that. Oh, we have reset the buffer. Okay. Yeah, it's not clearing properly. Guess that clear doesn't mean anything in this situation. Oh, we'll have to figure that out. It's supposed to, when it hits the last, it's supposed to clear the value. reset the values. I don't know why it doesn't do that. Okay, let's go see how the bit file is doing. Okay, so now we need to bring those over. We're gonna use our favorite mobile X term to do that. Okay, so we need to go find the files again. C drive. Up. AOC, date 1. So we're gonna go runs, implementation. We're gonna rename to day 1. Drop that over. Rename to day 1. Remind me to name the wrapper file the correct thing. And then we're gonna go to gen, I believe. Over handoff. So we just gotta name everything. This is what we probably want as day 1 anyways. That tickle file. Rename day 1. Okay. Let's see if this works now, because this is going to be part 1 DMA. This is going to be day 1 part 1. Okay, let's try this again. Okay, cool. That worked. Register map. Clear is gone. I wonder if we mess this one up. Let's see. It may be using the wrong thing. 0. Let's just run it once. Okay, we've seen what happens if we faster. Yes. I wonder if we screwed that up along the way somewhere. Well, let's try part 2. Wonder if we part 2 should be properly should have 1632. Okay. The last one not go through? And why is this one not updating correctly? Oh, 1601. We do it during 1602. Yeah, it looks like we're having a little bit of issue with the values. 1602. Oh, it's just the address different. Okay, register map. 1601. 1633, 16. Okay, we have an off by 1 issue. Maybe we should test these later. But for now, I think that's good. Showing how we got the HLS to work, how we were able to look at it. I'm not happy about that. But I think we've learned a lot of lessons here of what I can implement into day 2 tomorrow. But let's go ahead and this value, either this value or the next value. Okay. You completed day 1. And let's just go over a preview of what the next time is going to be. Okay, now you need to figure out how to pilot this thing. It seems that the submarine can take a series of commands like forward, down, or up. Forward, X increases the horizontal position. Depth, up decreases the depth by X units. Note that the submarine down, up affect your depth. And so they have the opposite result of what you might expect. You should probably figure out where it's going. For example, forward, up, down, forward. At 0, the following steps above would then modify them as follows. forward, resulting value of 5. Okay, forward as to your 13, up, okay, down, 10, okay, forward, 15. After the following instructions, you would have a horizontal position of 15. Multiply these together produces 150. Do you give you multiply your final position? Okay, and you get our puzzle input is something like this. Oh, we're gonna have to convert this to something. Convert our data to something we can use. We'll probably just convert that to a header of 0, 1, 2, or 3. Maybe we'll do some pound defines. We'll call that good. Okay. Okay, so we'll look at that another day. What other fun things? I should try to get an ETH hash review going up sometime. We have an RTX Ultra Scale Plus coming in, and I have this FTDI board I need to work on sometime. Plus Vitus AI. Feel free to add things to. Oh, I was going to add a post of what targeted FPGA you guys have. But yeah, just add things to comments or whatever of what you would like to see, and we'll